And put on the top of your desk, hands on your knees. No, they should be closed. No one should be touching their rocks. Your rocks do not go on your head. All right, so we got to talk a little bit more about stuff because we went, we found some minerals, found some fossils, but now we got to talk about them. So, who can remind me what fossils are? What are fossils? What are fossils?
Fossils are tracings of the past that were left by bones or markings.
Okay, so they were left by bones or markings. Yeah, so fossils are what are left of living things from the past. So anything living, what are examples of living things? Give me one example, Cooper.
Dinosaur, cave.
I said one example. What's another example, Cody?
Caveman.
Caveman, okay. Kaden, what's an example of a living thing?
I have to do one.
Mm-hmm.
Crocodile.
All right. So, fossils can be prints of animals or plants. For example, you see right here, we have a footprint of a caveman, yes. And then, but fossils can also be parts of things that were once living. So things like bones, teeth. They can also be, footprints, tracks, or even birds' nests. Those can be fossilized. So, if we look at these images, this here is an example of a print of an animal. This, I think it's called a cephalopod, if I remember. Yeah, it used to live in the ocean a long time ago. This here, what's that?
A dinosaur bone.
Dinosaur bone. Yeah.
And a footprint of a caveman.
And a footprint. So these are all things that can be fossil. Where can we find these things?
Museum.
Where else? Where can we find them?
You can find them at the zoo, the museum.
Museum, okay. Where else? Where else can we find them?
Maybe like national parks.
No. Okay. Reese?
In the soil.
In the soil. So we can find fossils in tons of different substances. Does anyone want to guess what kind of substances we can find them in? What can fossilize these living things?
Dirt and sometimes cave rock, water.
Okay. What about Penelope? Do you have an idea?
Yeah. It's when, like, if a bugs were in the dirt, and grass, they might, took out the grass and made some sidewalks. And
Okay.
it might have got, like, stuck in the side.
Okay. Mason, do you have any one that we haven't said?
They could be found, like, fossils could sometimes be found in the water. It doesn't depend on which fossil because the water keeps getting, like,
Okay. So many fossils are actually found in rocks. So
caves.
yeah, like Cooper and Penelope said, they get pushed into dirt and minerals, and those minerals harden into the rocks. They can also be found in things like ice, tar, and amber. So ice, obviously, the animals would be frozen in time. Does anyone know what tar is? What's tar, Kaden?
It's like something that you see often.
Kind of. So tar is going to be like a black sticky substance.
Like a very slime pit, but very sticky.
Yeah, it's similar to that. Does anyone know what amber is? I know it says it on here, but have you seen it? Roger, what's amber?
Well, I was about to say that at first,
You thought what? Bugs weren't supposed to be in caves? Well, let's think. Is a bug a living thing? So then can I fossilize a bug?
Yes.
I can. And an example is right here. This is a mosquito and it's in what is amber, but amber is also called tree sap. So amber is just hardened tree sap. So you know how like people will go to trees and get the sap to make syrup?
Yeah.
This is just hardened, kind of like syrup, but they didn't cook it down. What about minerals? What are minerals? Luke, what's a mineral?
Mineral is like something that can be made into a rock or that we.
Yeah. What's a mineral, Liam?
Minerals is gems.
Gems? Yeah, gems are an example of minerals. What's a mineral? Cody?
A mineral turns into a rock that we cannot do.
Okay. So minerals are solid objects that are formed in nature and they have never been alive. So all of the minerals you have in your bag right now, those were never living. The only living thing you could possibly have is that petrified wood. Which I don't know if all of you got. Don't touch your rocks. Don't touch them. I see you guys going for them. Don't touch them. Put your bags down. Hands on your head. Hands on your head. All right. Don't touch your rocks. You can take your hands off your head. So minerals are things that have never been alive. Minerals are made up of one material, and it's usually the same material throughout. There could be a little bit of color variation. You got a question, Penelope? But it's made out of one material. Do you know why a mineral is only made up of one material? Elizabeth Grace?
It's made of one material because it was formed by rock and it formed into minerals.
Okay. Minerals were actually not formed by rocks because rocks are actually made of aggregated minerals. Does anyone remember what the word aggregated means? I want you guys to think. What does the word aggregated mean? Zoe, what does aggregated mean?
Sort of collected.
Yeah, that's exactly it. So aggregated means collected together. So if you look at these images, do you see how there's multiple different like little specks? You see, what colors do we see in this one?
Orange, black, orange, brown, white, and a light gray.
What about this one?
Light black, white.
What's in that third one? What,
Brown, tan,
Kind of brown,
so these are examples of different. Yeah, these are examples of different rocks. This one is granite, and it's made up of things like. I'm trying to think. Sorry, it's made up of a lot of different materials. You guys might see granite often because it's usually used for countertops. Yeah. This one, has anyone ever seen sandstone before?
It's in desert. It's sandstone.
I
used to live. It's in the desert.
Yeah. Sandstone is another type of rock that is made up of many different materials. So, I want you guys to think, where can we find minerals? Talked about what minerals are. I want you guys to think. Think of a few places we can find minerals. And I want you to turn to your shoulder partner and tell them what different places you could find a mineral.
Because
Arizona.
And also the national Indian
So, what are some places I could find a mineral? I want you guys to just give me one when I call on you. Chase?
Caves.
Caves. Chloe? Deserts? Yeah. Patrick? Underground. Okay. Emma?
National Park.
National parks. So you see how that we listed a lot of different places, like a desert's very different than a cave. Well, that's because minerals are found all over the surface as well as deep underground. Yeah, and underwater. But it's kind of hard sometimes to get to that underwater, so we mainly stick to getting them from our surface. See this big mining operation here? Kind of hard to see. Those are big trucks, and they're way down there, and they're taking kind of like the stuff, yeah, the gravel that was used as our ore, our mining ore. They're getting the mining ore and they're taking it to a machine that does what you guys did. So they're gonna take it to a machine that sifts. So, let's think. What are some things that we can use to identify our different minerals? What do you think? What can we use to identify? I want you guys to think just for a few seconds. And I want you to turn to your face partner this time and tell them, if you're a group of three, just share. If you want, how do you think, Roger? How can you identify the What do you guys think? What is something that we can use to identify a mineral? Which mineral we have? Kaden, what is something?
So let's say that you have something at Diamondale, and then you turn on the water for a little while, and then you can pick out whatever you found, and then get a microscope and see what you found.
How do I know what I found though?
By having a list of
A
stuff,
list? Okay.
and then you can like match it up.
What do I match up?
The walk.
Oh.
The walk to
What
whatever.
can we use? What features of the mineral can we use to identify?
Like the colors.
Colors, yeah. Luke, what else can we use?
A book.
Book, okay. Maybe. Buddy, what could we use?
Shape.
Shape, that could be useful. Or Zoe? Feel. So, yeah. So one of the things is we can use color. We can use what's called hardness, which is how easily that the mineral could be scratched. I have a chart right here. This is called Mohs hardness, yeah, sorry. And it has them ranked. So a diamond is a 10. That means it's really hard to scratch it. Well, we have what's called tau at a 1, so it's really easy. There's a few on this one that we have, like the calcite. You guys found calcite. If you were to take a penny to calcite, you'd be able to actually scratch it. Maybe that's a cool trick you can show your family later. Under calcite, it's called gypsum.
What's gypsum?
Huh?
It's literally up there. It's up there.
Gypsum is interesting.
Fingernail.
But another thing we can use to look at and try to identify is called luster. So luster is how the light reflects off of the mineral. So if you guys remember when we were in the truck, did the minerals look different when you held them up to the light?
Yes. No.
What were some things you noticed when you held it up to the light? Patrick?
Different shape.
Different shape. Okay. Did any of them reflect light?
Yes. The diamonds.
I don't think there was
All
diamonds.
the there was no diamonds.
What ones? Do you remember?
Well, this is one. It was this one right here.
Ah.
It's like kind of clear and it like.
Oh yeah. I know what you mean. So, another way you can identify the mineral is called density. I think we've talked about density before in science.
Yes.
Have you? So density is how heavy it is. So like you would have to have a scale to do density because you would weigh them. If you had two similar minerals and you didn't know what it was, you would weigh it and see is it a very dense material or not. So now we get to watch the Diamond Dale's after video, okay? So he's gonna go through this and he's going to help you guys kind of determine what minerals you have. I want everyone to put your hands on your shoulders. You guys do not need to be touching your bags of rocks currently, okay? Just pay attention to this video because he's going to talk about the different rocks he found and help you guys try to determine how to identify them, okay? Because you guys get to do some identifying. Question, Kaden?
I see this one right here. What is this?
You'll find out. Remember what I just said. Diamond Dale's going to help you try to figure out how to identify. So pay attention to what he says.
Diamond Dale. And what I'd like to do in this video is I want to identify all the gems you found, and I also want to teach you how geologists classify and identify rocks and minerals by examining their physical properties. And I have a short video I want you to watch in which they explain to you what the physical properties of rocks and minerals are. And after this little short video, I'll come back on and I'll identify all the things you found, and then I'll help you classify and identify them. So take a look at this video and I'll be back in a few minutes.
Identifying minerals is challenging because there are so many kinds. Geologists try to figure out what they have by testing physical properties. Physical properties include such things as color, hardness, luster, density, and other features that make a mineral look the way it looks and do the things it does. Color is an easy place to start. Sulfur is yellow and azurite blue. But color is usually not enough. Quartz, Earth's most common mineral, can be many colors. However, quartz is harder than most minerals. It resists scratching even with a knife. Geologists can compare any mineral's hardness to Mohs scale. Mohs scale ranks 10 common minerals from the softest, talc, to the hardest, diamond. Another physical property, luster, refers to the way a mineral reflects light. Some minerals have dull surfaces, others shiny. Density is determined by how heavy a mineral is. These two minerals seem to be the same until you feel their weight. Minerals may also be tested for magnetism, the color of streaks they leave on a rough surface, and even the way they break apart or cleave. Mica, for example, cleaves into thin layers like sheets of paper in a stack. When hit with a rock hammer, calcite cleaves neatly into slanted boxes. Fluorite cleaves into this remarkable shape. Testing each physical property, such as cleavage, hardness, and color, takes the geologist one step closer to identification. Geologists continue testing physical properties until a mineral is identified.
Okay, welcome back. I hope you learned something from that video. And what I'd like to do now is I want to hold up some of the things you found and tell you a little bit about them, okay? Now, the first one I'd like to show you is the February birthstone. This is the purple amethyst. And one interesting fact about amethyst is it's the most popular stone worn in jewelry. In fact, more amethyst is sold than diamonds. So it's very popular, it's very premium, it's cut and polished. And people who were born in February especially like this stone because amethyst is the birthstone for February. And amethyst is nothing more than a quartz crystal that turned purple while it was forming. And that's our amethyst. And the next one I want to show you is this one. This is a quartz crystal, okay? And quartz is the most abundant mineral on Earth, and quartz can form in many different colors, shapes, and sizes, but when it crystallizes, it'll have a point and 6 sides. So if you found one that wasn't broken or crushed coming out of a gem mine, it should have a point and 6 sides, okay? And as I just said, there's some other quartz besides quartz crystal, and this is a very pretty quartz. This one is called rose quartz. And look, rose quartz is actually pink in color, but the color probably won't show up on this video, but I assure you it is pink, okay? And because it's pink, rose quartz has a nickname, and the nickname for rose quartz is pink ice. And this next quartz is called snow quartz, and it's pretty easy to see why they call it snow quartz. It's as white as snow. So I hope everybody found some snow quartz. And this next one is one of my favorites. This one is called pyrite. The pyrite's best known by its nickname, fool's gold. And as you can see, it sparkles like gold, it has a gold color, and it's also very heavy like gold. So that's why people are easily fooled by it, and that's why it got the name fool's gold. Now, you heard in the video that one of the physical properties of rocks and minerals is the streak it leaves. And what that means is if you take a mineral and you rub it on a tile like this, it'll leave a certain color streak. And the geologist can use that color to help determine what type of mineral it is. For example, I have people ask me all the time, how do you tell the difference between real gold and fool's gold? Well, one of the best things you can do to tell the difference is do the streak test. So what I'm going to do here is I'm going to take this fool's gold and I'm going to rub it on here and we're going to see what color streak it leaves, okay? All right, now boys and girls, if y'all can see that, the fool's gold left a black streak. Even though it's gold in color, it left a black streak. And that's how you tell the difference between real gold and fool's gold. Because if I were to take real gold and rub it on here, it would leave a yellow streak. This next one is called moonstone. And moonstone got its name because the ancient Egyptians used to find this in the desert, and they couldn't figure out where it came from, so they thought it was moonbeams that hit the ground and turned into rock. And moonstone today is used in a lot of carvings. People make little figurines and stuff like that out of moonstone. And this next one is called orange calcite, okay? And you may have heard of calcite before because it has calcium in it. And calcium is one of the minerals that they put in antacids like rolaids and tums. This is the orange calcite. And the interesting thing about calcite is if you find a real pure piece of calcite and you put it in an acid, even a very weak acid like vinegar, it'll fizz and bubble. If you have a real pure piece, you can try that. If you get a chance, and you may see some little bubbles coming off of it, you can really tell if you put in something like hydrochloric acid, but don't do that unless you have adult supervision. But that's our orange calcite. This next one is green opal. And some of you may know opal is the birthstone for the month of October, but most people recognize opal as kind of a bluish white color mineral, but most people don't know that opal is found in many colors. And this one's sort of an army green. It's a unique color, but it's very pretty. So I hope everybody has some green opal. And this next one's one of my favorites. This one is called fluorite. And I'm going to hold up several pieces of it here for you. And fluorite can be found in many different colors. Green, clear, purple. Some of the purple even looks like amethyst. And in a minute, I'm going to share how to tell the difference between purple fluorite and purple amethyst. But if you get real lucky, you may find one like this one and find all three colors. You can see the green there, there's the clear, and then there's the purple. And fluorite is used in toothpaste. You've heard of fluoride? Well, it comes from fluorite. This next one I'd like to show you is the only fossil you should have in your collection. This is called petrified wood. And petrified wood is a tree or wood that fossilized after thousands of years of being on the ground. What happens is when a tree dies and it falls on the ground and it gets covered with something like mud or volcanic ash, the oxygen can't get to it to deteriorate it. So what happens is the water will come in there and leave minerals, and they will harden and petrify the wood, fossilize it. And that's our petrified wood. This one is a beautiful blue mineral called apatite. And you don't see many blue minerals. This is very special because it is the color blue. And I'll tell you an interesting fact about apatite. Some of the rocks that the astronauts brought back from the moon contain apatite. So we know that this mineral is actually on the moon. And this next one is one of my favorites. It's called tiger eye. And the reason they call this mineral tiger eye is because it looks like the eye of a tiger. And you heard in the video you saw about one of the ways that, one of the physical properties that geologists use to identify rocks and minerals is the luster. And the tiger eye has a beautiful luster to it. And the luster has to do with how a mineral reflects light. Some minerals are transparent, which means the light goes through them. Some minerals are translucent, which means the sunlight will go through them. And then the tiger eye actually reflects all the light, and you can see a beautiful shine to it if you hold it up to the light. And that's the tiger eye. Okay?
All right. We're gonna stop the video there. He went through most of them. The only one he didn't go through was garnet. And he went through what garnet looks like in the actual trailer. It's the little tiny red ones that you got. But what I want you guys to do, I gave you all a little identification chart. You're gonna take a few minutes. You're gonna choose a couple of your rocks. You're gonna try to identify them. And then using that paper, the Venn diagram that I put on your, let me go. So using this Venn diagram you got, you guys are going to identify two of your fossils, and then you're going to compare them using color, the hardness, which it tells you on the identification card what the hardness is. If you look on the back, it tells you the hardness, and then you're going to look at luster and also the texture, how the rock feels. So you guys have a few minutes to do that, so go ahead and get started. Two of How about you choose one of them and then that one?
I can't find my title. Yeah, here's the mix. I got a bunch of these. There's my amethyst. Here, there's my amethyst. I can't believe I got scared. And it got full. I got it too.
What do you know about that? What do you see?
There's no way glowing. I have a mix. I have that mix. I have like a million. It's the same. I have that mix of the yeah, that's what they call. I think
What time is it?
Oh, you're allowed to take all of them out? There's my I can look at them. This is number 12. You do have a fossil. Remember? Where's mine? Petrified wood. Where's mine?
You guys didn't write it?
Yeah, we're trying to get everything
All right, guys. I know we didn't get a lot of time to really look at our rocks, but we do have to switch to math now. So I want you guys to take your rocks. Yeah.
everyone.
So I want everyone to take your rocks. Take all your rocks. Make sure you get them all back into your bag. Then you're going to seal your bags up. Okay, hands on your head. You need to listen to my directions, okay? You're going to put all your rocks in your bags, and you're going to take your bags and you're going to put them in your book bags, okay? Make sure it's sealed. If you need help sealing it, let me know. But you need to make sure you get all of the rocks, even those little garnets.
I didn't take mine out. I didn't take my garnets out.
You want them to just take that Venn diagram home? Yeah, that's Can you get all your garments? Come on, guys, gotta pack up. You can take that for two.
I am 10.
So let's, which ones are purple?
You have one volcanic rock. I have 10.
12, 10. What about
Oh, then I have a bunch. Half mine.
Alright, you guys can put the Venn diagram in the gym rock and mineral identification chart. You can put that in your take home, stay home. And Miss Roses, get ready to go to math class. Come on, Zoe, you need to put that stuff away. You gotta go to math. You gotta go see the Come on, Roger. Whose green pencils on the floor over here? Let's go. Put your stuff up. Get ready for